So look, tonight we're running through a presentation that's been given by the Earth Moving Equipment Safety Roundtable lead. So Eve, if I could have the next slide. Thanks. So I was going to give everyone a bit of background on the ICMM Health and Safety Society. So I think most of the members who are on the line will be well aware of what the Institute's all about, but it's really a place for resource sector professionals to participate and share professional views, professional ideas, and really to help nurture the growth of our industry across the board and within Australia and Australasia, and also supporting the global initiatives. So our committee is made up of multiple people. At the moment, we've got a 13-person committee, and we've got a fair then. And we've also got the ability to mute ourselves if you click on the mute button. That'd be awesome. So thanks for that. So finally, if you want to update your profile, you can do so at that link there. Again, I think I'm right in saying we will share the presentation and also the recording of this presentation with the broader group after this session. So Eve, if I could get the next slide. So one final plug for all things related to the Institute, which is the Health and Safety Society is also a keen supporter of the MindSafe International Conference, which due to COVID has gone digital, and that's on the 22nd and 23rd of September. So I'd strongly encourage everyone to look at signing up and joining that conference. Look, without much further ado, I'll go to the next slide and introduce our presenters tonight. We're very fortunate to have such an erstwhile group of professionals come to speak to us. And so we've got the key people within EMESRT in the form of Tony Egan, who's the group manager and lead. I won't read through everyone's skills and experience. I'm sure you can do that at your leisure, but Tony brings a wealth of experience and has been closely involved with developing vehicle interaction improvements across the industry for quite a few years, similarly with all the other presenters on the line. So you've got Ian Curran, who's Global Manager, Asset Management for BHP, Mark Gearson, HME Principal Advisor, and also the AMCOE, which the COE I know stands, Asset Management Centre of Excellence. He's actively involved in that within Rio Tinto. And my colleague Mike Boyle, who's a Director and Principal Consultant within Risk Mentor, bringing science, hygiene qualifications, and also a depth of experience around systems development. Finally, our long-suffering EMESRT coordinator, Eve McDonald, has got formal qualifications and over 25 years experience in the research sector. So without any further ado, I'll hand over to Eve and look forward to all of the questions, feedback, and the ebb and flow of information as we move through the night. Thanks, Eve.
Thanks, Pete. If we can just go through some housekeeping, that'll be really appreciated. If you could turn off your video, that'll help with the bandwidth. If you can mute your audio, unless you have a question that we need to ask you, etc., please do that because that'll stop any background noise. Use the chat function to ask any questions. We'll address questions following each of the section. We are monitoring your questions, so if you do have any, we will address as many as possible at the end of each of the sections. So you know, we are recording this presentation, and that's basically to have the presentation for future use and to share with ICMM and EMESRT and so on. If you do have any questions that you've missed out on tonight, please do send me an email and I'll get the guys that are presenting tonight to answer any questions that you might have. You can see my email address there on the screen. If I can just go through the agenda that we've got for tonight, it is split into 3 sections like I mentioned. We've got part 1, section 1, about EMESRT, and that'll be presented by Mark Gearson. Part 2 of section 1 is VI Industry Project, the compelling case, Ian Curran. Then we'll roll over to section 2, where we have part 1, VI Industry Project Overview 2013 to 2020. That'll be presented by Tony Egan. Part 2 of that section is project learnings after 7 years of work, presented by Ian Curran. And then we'll move over to section 3. Part 1, next steps 2020, is about delivery, and that'll actually be presented by all our presenters tonight, which will be quite interesting. And part 2 of section 3 is operating site application, and that'll be presented by Tony Egan. Sorry, my bit of paper just pressed the keyboard. If I could just get Mark Gearson to start us off in his presentation, introducing EMESRT and giving us a bit of an overview on about EMESRT. If you would please, Mark.
Yeah, thanks, Eve. And thanks to ICMM, EMESRT and Rio Tinto for the opportunity to talk to this important piece of work. So what's EMESRT? EMESRT is a mining company organisation that was formed in 2005 to influence OEM designs by establishing a common voice on health and safety issues and to deliver practical outcomes to long-standing industry design problems. We really had to think differently because what we were doing was not working. The key to this was to influence marketing because they control investment in research and development. What drives marketing is a business case underpinned by critical mass of users who are aligned on a detailed understanding of a common problem. So EMESRT facilitates the alignment between mining equipment users and designers. Next. Thank you. Our key purpose is to accelerate the development and adoption of leading practice design to minimise the risk to health and safety through a process of original equipment manufacturer, contractor, and user engagement. So standards and guidelines are useful in locking in change, but they don't lead it. The visual in the bottom right-hand corner is really an excellent way to summarise how we engage. We designing beyond standards, and this will become particularly important as the presentation moves on. Thanks, Steve. So EMESRT is a well-recognised industry brand and has been successful for the last 15 years through these 5 key factors of success. We've got an industry-level focus, a real-world business understanding, innovation, understanding that innovation is market-driven, really good governance, and senior management decision-maker endorsement. Next, thanks, sir. So, I guess there's a couple of key points here. We begin with a problem definition to develop a deep understanding based on our operational experience. We don't immediately go to engineering solutions. So there's 2 key innovation categories. The first is the operational innovation, and these improve or do better what we do now. And the second innovation category is step change innovation, and that replaces what we do now. So importantly, successful projects that improve vehicle interaction controls introduce innovations from both categories. So I'll now hand over to Ian Curran to present part 2 of this section.
Thanks, Mark. VI, the compelling case. Yes, I think if we look back to the start, in 2013, collision avoidance was becoming a common term across the industry. The mining industry had not really addressed the rate at which we were, either severely injuring our people and even killing them in vehicle-related incidents. The Inspectorate was trying to apply quite some pressure, and certainly South Africa was leading the charge in this space. If you can change slides, please. I look back, I did a very early body of work, which is shown up here in some respects, that mapped both vehicle intensity and known event density and overlaid those models on top of each other. The results very quickly highlighted areas on a mine site that warranted investigation. This work really formed a lot of the work that went into operational risk and form the first layers of the 9-step model that we'll discuss later in the presentation. But you can see the hot spots across the screen in red once you overlay those incidents and traffic intensity to see where you should be focusing on a mine site. Based on this body of work, and it was quite some work that it took me to get there, I took some of these ideas to immerse with the message that vehicles are driving and now become the burning platform across the industry, and that we really needed to do something as the EMESRT organisation. Next slide. It was interesting, anybody that could produce a GPS-enabled device announced to the world they could do collision avoidance. The regulators got on board very quickly and started mandating collision avoidance systems. What EMESRT saw, though, was the problem was not well understood, and the solution was not as simple as we were told. We identified several industry-level opportunities to share and build knowledge, bring together both OEMs and PDS suppliers to work on a common way forward. And Tony will talk on this journey next up. In review, though, the work done in 2018 by ICMM showed clearly that nobody had quite got it right yet. Many products that appeared in the market due to no boundaries being set very quickly disappeared. The language changed and a roadmap to go forward had been well developed, and industry collaboration was very evident. I'll hand over to Eve now to see if there's any questions. Thanks, Eve.
Thank you, Ian. If there are any questions, I'll just have a look at what the chat's been about, if I could. I can't see any chat, so that's good. We'll move on to the next section. If there's no further questions, and I can't see any at all, I don't know if you guys that are presenting can see any, we'll move over to section 2, part 1, with our presenter, Tony Egan. Tony, if you will, please.
Thanks, Eve. I'm just getting... Oh, right. I'm getting a bit of lag on the screen changes, so forgive me if I wait a bit on things. So my role in this section is to talk about the journey that we formally started in 2013 that Ian just spoke about. And it's been an interesting few years, so please move on, Eve. So this project on VI, and we talk about it as vehicle interaction, not collision avoidance, not situation awareness. A lot of things get mentioned, and they were mentioned years ago, but the problem we face is actually vehicle interaction. Some of the things that we talk about, say for instance, proximity detection or collision avoidance, are actually controls that help us deal with this stuff. But it's about defining the problem. We brought together, as part of this project, a range of companies, some outside of the EMESRT membership, and that's not an issue, and also OEMs and third parties who are involved in this space to work on this project because it's so big, it's so complex, and there's lots of moving parts. So this group's been working together now since about 2015, this broader group, and you'll see later on that they're also involved in some of the other activities. Thanks, Lee. I've got a bit of screen lag going on.
Yeah, it's gone to the
journey.
Yep, timeline.
Thanks, Eve. So the journey that we've been on, really in terms of the formation of EMESRT in 2005 and formally into 2006, where we went on the first visit to the OEMs and talked to them about a different way to communicate between the users and themselves. But as I said, in 2013, it really started in earnest when Ian walked in the door and said, there's this burning platform around vehicle interaction. And he just showed you some of the reasoning why he came through the door. The journey for myself has been involved internally in Glencore since about 2015 into running some projects. And the learnings that have come out of that have also been flowed freely into EMESRT, as has some of the other businesses involved. One of the things that we've done is there's no boundaries in this space, and we need to really learn from each other if we're going to move ahead quickly. And you'll see that there's been a lot of different activities going on. I'm not going to go through all of that, but really I think the last 12 months is where we've made some significant breakthroughs on our depth of understanding, and I think we're really moving forward about working with the OEMs and the third parties about how do we get a better outcome. Eve, I see there's a poll popped up in the middle of the screen.
Yes.
It's still there. Are you able to get rid of that? Eve, the polling questions are in the middle of the page.
Are they? Okay.
Mm-hmm.
Probably on your own screen. You should be able to move it yourself, maybe.
I think so. Righto, sorry. Not getting used to this. Please go to the next slide, Eve. Thanks for that.
Okay, you got the new slide.
Yep. So I talked about the breadth and complexity of this thing. A couple of years ago, we put this thing together, what we call loosely the array diagram. And what I tried to do was articulate on one page all of the moving pieces that relate to vehicle interaction activity, both at research level, OEM level, industry level. And there's quite a bit of activity there in the green that EMESRT itself has been doing. And what it showed is it's not a one-stop shop. It's about everyone coming together to solve this stuff. And we've made some good progress. So you'll get a feel later on about these moving parts and how they've all come together. Next slide, please, Lee. I've just lost signal. Sorry, guys. I'm now connecting again.
Tony, I know that you're in a bad spot, and a lot of our webinar participants wouldn't know that you're out in the middle of Whoop Whoop with, bad internet access. So I do apologise for any interruption. Tony has to wait a little bit for the slides to come up. Do proceed, please, Tony.
What I might do is I'll just work off a set that's on the email and see if you can just move them for everyone else.
Yeah, so we've got the 9-layer control.
Yep.
With the design, operate and react visual.
Okay. Thanks, Sue. I've got it now. I've got another copy running. All right. So this model sets out something that's really important that we found in vehicle interaction is that you can't just look at the technology piece. And, you heard Ian talk before about the design, operate and react. Well, when we first started on this journey, people kept talking about the silver bullet. Just give me a bit of technology and that'll solve all my problems. Well, it actually doesn't. And if you're not dealing with all of the moving pieces, then you're going to come unstuck. So a lot of the work where EMESRT was typically involved with the designers in the beginning is coming back to the users as well in terms of the management systems that we have in place and how they work in concert with the technologies that you're putting in. So it's pretty heavy focus. And the reality is that, you want to be in the design and operate stages. When you get into React, it means you've got some real problems and you don't want to be there. So if you can improve your level of 1 to 7 there, then you're going to lower your exposure. So next slide, please, Ed.
So you've got the control classification level definitions up.
All right, thanks, Ed. So one of the other really key pieces that came out of the work that we've done in the last 12 months is changing the definition of what we call level 7, 8, and 9. So 7 being operate awareness, 8 being the alarm and alert, and then 9 is really intervention. So what's come about is that the original version of this was published in 2015 when we were in the early days, and it was very much driven by the designers because that's really what we'd focused on in terms of our understanding. This body of work now has changed, and we've published this year, which is really coming from the user perspective. And I'd ask you to think about when you're driving down the road and a dog or something runs out from behind a car. At level 7, there's some issues around awareness, what's going on. And so if you think about the questions that this asks is that really, where is it, what is it, how far away is it, what's its heading and how fast it's going. Your brain does this in a nanosecond. And it's amazing how a human can perform these functions so quickly. what we're trying to, why the proximity detection and the collision avoidance systems have been struggling, and Ian talked about lack of maturity, is the fact that they don't process all of the stuff that a human processes. And therefore there's gaps. And so the interaction with the human for the bits that the machine or the technology doesn't do creates some problems. But the real issue in 7 is it's there to enhance the situational awareness of the operator, and gives, depending on the type of design, it can give some better visual confirmation. In terms of 8, well, the real key here is that it's a technology that alarms or instructs during what's really going to be an imminent threat. So in 7, you're still in reasonable shape. In 8, you're an imminent threat. And the system really should provide a specific instruction, because it's starting to create some logic. And then it really needs the ability then of the operator to assess other contributing factors about how fast am I going, am I loaded or unloaded, is the road wet or dry. There's all the contributing factors. Again, the proximity systems and collision systems currently can't do that. Even some of the autonomous stuff can't do that. So it's really important to understand that you still need the human in a lot of respects. And level 9 intervention is that it takes the logic from 8, and instead of sending it to the human via an interface, it sends it by a direct interface to something on the machine. And the level of intervention is actually quite narrow. Generally, it's just braking. And at this point, if the vehicle's going quite fast, it's just slowing and then eventually braking. It's quite limited. Next slide, please, Ed.
Yep,
in terms of developing, thanks, Eve. In terms of developing an understanding of those 9 layers that I spoke about a couple of slides ago, we used an approach called the control framework, and what it's been born out of is, I suppose, a whole piece of work where we all had used different techniques for trying to understand things in our businesses. And ultimately, we came across the approach of literally what's called failure modes effects analysis, but with a very much more of a human factors bent about how's the human failing, because typically failure modes effects is more around the widgets. We also took into account the work that had been done at the International Council of Mining and Metals, and that was born out of some work that was done in ACARP, the Australian Coal Research, with Professor Jim Joy and a bunch of other learned people around the definition of what is a new control. And that was born into this ICMM work, and we carried it on. And that new control thinking is around either things are either an act, an object, or a technological system, and that being technology that changes state and then a human acts upon it. So that level 8 section I spoke of a minute ago is actually an example of that. Next slide, please, Eve.
Ready.
So what is the control framework? Pretty simple, really. It's really about saying that we deal with these things every day and we actually get them right a lot. However, in the past, we've tended to focus more on how we get them wrong. And that gives us a very narrow view of things. So what we've done in the control framework is to say, how do we do everything in relation to vehicle interaction? And it was quite a thorough and detailed approach, but simpler than you might think. And what it does is capture what we call the required operating states. So things like, if you maintain speed, you park correctly, you give way, you drive at speeds appropriate to the conditions. Those sorts of things mean that you're actually getting it right. So then the flip side of that is having to find those, what are the ways that we get it wrong? How do we lose those states and their credible failure modes? Other people might call them erosion factors. It really doesn't matter. In an incident situation, we often call them contributing factors. So ultimately, once you've identified those, then the business inputs are things that we actually do every day, our people do on the ground, to actually mitigate those credible failure modes occurring. And the way that we capture the business input is, what do we specify, implement, and monitor? So for instance, we specify the speeds on site, the design of the roads, those sorts of things. We implement them through training, through physical road designs, etc. And we also then monitor the performance. The real challenge we've had is that most of the key the key things that you control in the vehicle are acts of a human, and they're actually hard to monitor. But we're starting to get technology that helps us in this space. And you heard Mark talk about before, technology that helps us do better what we do now. Well, a good example of that is the fatigue stuff that's around at the moment. You know, we didn't know, well, we knew people were having microsleeps, but we didn't really know how and when. And we're starting to really manage that now because we're starting to understand not only alerting the operator that they've had one, but we have the data to go in and intervene. And we've seen dramatic shifts in people's behaviour and their preparation for shifts using that approach. So control framework sets a really good base. Next slide, please, Eve.
Ready?
The flow on from that was, I said that there was a range of required operating states. We've captured 13 in that list on the left-hand side there. The failure modes, we've then grouped, they're quite a lot of them, but we can group them into things such as the controller. And that could be either the human or a machine intervention, whether the equipment's compromised, those sorts of things. So you start to filter things down and you get a really broad picture of exactly how everything's functioning, not just a slither of something. And at the end, the bottom there, you've got the business inputs. And they fit into some pretty neat categories, really around people, equipment, and the environment. And so with all that in mind, you can really start to interrogate. And we've certainly used this now in incident investigations, etc. You know, you go in and say, which were the states that were lost? Which were the failure modes within those states that occurred? And therefore, was it, you know, the specify, implement, or monitor of the business input that actually led to the outcome? And often we're finding that we've actually specified stuff pretty well. It's our ability to implement and monitor is probably where we struggle. Next slide, please, Eve.
Ready?
Thanks, Eve. So the control framework led to a couple of different variables. One back towards users. So we've got this tool which is going to get talked a little bit about later on called the Self-Assessment Review Guideline, SARG. Always good for an acronym. Engineers always have 4 letters. And what it does is gives you an ability to go through the control framework, because what we're finding is, having done this across a lot of sites now, it's quite consistent. When we started this, I had mine managers and others saying, oh, you know, we're different. It's Queensland, New South Wales. We're a different company. But what we're finding is we all drive big bits of equipment that run into little bits of equipment, and we all drive on similar roads. And what we're finding out of the control framework is a lot of similarity. And the other thing that's flowing on into now is you get into a self-assessment process and you say, well, okay, well, I want to change because I've found some gaps. Where might I get some information? And we're putting together what we're calling a knowledge hub, and deliberately named that, not a database. It's meant to be a knowledge hub, so it's about quality, not quantity, of information that people can go to. And we've set it up in a journey model. So depending where you are along your maturity of going into the process of vehicle interaction, we've tried to create an entry point that you can get to the information you need quickly. On the designer side, so that's the user side, on the designer side, we've derived a set of functional performance requirements that have come out of the control framework and are linked to the failure modes. And the designers are finding this really useful because we're giving them what the outcome is, how we get it, how we lose that outcome, and therefore what could they do in terms of changing the technology or inventing new technology that can help us close the gaps. So the original functional requirement statements were quite broad and overarching, and they're not really deep enough to give a designer all of the detail. And you'll see an example later on where we've got these storyboards we've created, which are really scenario-based specific points where we can provide great detail to the designer and get down to a level where they can actually really finesse this stuff. Next slide, please, Eve. Oh, I beg your pardon, last piece on the right-hand side. The operating site application, we're going to talk a little bit later, but we've actually derived a work breakdown structure to establish a project whereby all of this comes together and actually allows you to flow through the journey. Thanks, Eve.
That's the last one for you.
Thank you, Eve. Sorry about that, people. I'm sitting on top of a mountain in the middle of nowhere. I'm actually on leave. I have to go and get some signal.
No, we appreciate that. Thank you very much. We'd like to now call on Ian Curran to present part 2 of section 2. If you wouldn't mind, please, Ian.
Yeah, thanks, Eve. As Eve said, look, section 2 will cover off on the 4 bullet points. If you go to the next slide, that are highlighted up on the screen here, and we'll go through some of the learnings of the journey as part of that. The first bullet point around performance requirements that support the design philosophies. EMESRT's got 8 design philosophies, of which number 5 is machine operations and controls. We saw quite early on that the design philosophy, as much as it was a great document, didn't have the detail to cover off what we needed in for vehicle interaction systems. So therefore, really, we built this performance requirements document called PR5A. Now, the first steps of that performance requirement document, PR5A, was to really understand what the problems were to make sure that there was a common, simple language. And on the next slide, look, we developed 24 scenarios of vehicle interaction scenarios based on industry data that really broke down into 4 key elements. So you can see the 4 different color boxes. The red, equipment to person; the green, equipment to equipment; the larger blue, the smaller blue box of equipment to environment; and of course the loss of control purple box. And certainly, those drawings in simple terms allowed us to get a very simple grasp of the problem. If we move to underground and go on the next slide, thanks, Eve. Underground again had very similar scenarios. However, one thing that was quite evident as we went through the work was that the vehicle speeds and constraints of underground workings changed some of the focus areas. And so far, we have necessitated a few different solutions just because of the confines of working underground. But the scenarios, and when you break them down into the potential unwanted events, don't change. Equipment to person, equipment to equipment, equipment to environment, and loss of control. I think the main thing with this body of work was at least now we had a common understanding of the language and the interactions we wanted controlled. Language, most people can say, oh, we've got one of these and can do this. Without this very simple breakdown of the structure, we weren't quite sure what people were saying. So it's a really important body of work. Another piece of this, we're now able to communicate the problem as well and draw the picture, highlight the priorities. If you go to the next slide, based on that body of work, EMESRT began evolving the key concepts of the 9-step model that Tony had mentioned a bit earlier, and I also mentioned. And these tried hard to describe the control effectiveness at each level. So in that design phase and the early phase of mine and key areas of focus, these controls really minimize the exposure. I talked earlier in my slide about that exposure piece and overlaying it over intensity. It's very important. In the operate space, controls that deflect the potential threats was really important. Fitness to operate, authority to operate, things like random blood and alcohol tests, drug testing, fatigue monitoring systems, all fall in that sort of area. And of course, we go to the last area, react, as Tony called it, the silver bullet, or so everybody thinks it's a silver bullet. It's that last chance intervention. When it's all gone wrong and we're in the milliseconds before a crash, is that where we really want to be working? It really is quite interesting. This is the area that the regulators focused on that said we had to do something here without going, actually, we should be doing more in the early stages. When we take this concept a little bit further and we go to the next slide, we actually looked outside the industry to validate some of our thinkings. We brought in the Mika Ansley human factors model. Mika Ansley, she was the chief scientist for the US Air Force for quite some time and now works in the Pentagon and is an expert in human factors in the aviation world. We started trying to align our 9-step levels to her human factors model that clearly articulated what we want to express to an operator at each of these levels. And if you look at the alignment there, as the environment changes, we need to perceive that change. And what's the best action for that scenario? Really some form of operator awareness. And we sort of things like screen changes, color, brightness, etc. Are those awareness things that work? It needs to be communicated at that right level. There needs to be discrimination between the messages. We provide our operators lots of alarms on a machine, and they all sound the same, and they all go beep, and they all go beep way too often. As you move through those levels of awareness and alert and alarm, you know, the message needs to change and needs to increase in what it's trying to tell you, what it's trying to do. So as you move through the McKenzie model of comprehension and projection, and then making a decision and taking action, the 9-step model follows that very clearly, and the alarms change from, you know, awareness to an alert, from alert to alarm, and then at level 9, the action piece at times, the truck may actually take control over itself. And that really is, you know, collision avoidance and intervention controls. So certainly there's a lot of work in trying to line those models up with how a human reacts to, you know, the environment around them. What do alarms mean? When do you become desensitized to an alarm? When does an alarm mean something different to what you thought it meant? So if we go to the next slide, I think, you know, that models and those models really provide some food for thought. And you know, as you go through, you know, in a little bit more detail, and Tony will take us through more of this as we go through some of the storyboards. But Eve, are there any questions on that body of work?
Okay. Yep, I'll just mute one person. Okay, if there are any, now I'm echoing now. If there are any questions, could you please use the chat functionality in Zoom? Okay.
Geez, it's a tough audience tonight, Eve.
I know, no questions so far. Okay. It would be good though, while we do have a bit of a lull in the presentation, if those online could actually provide a little bit of a chat as to who you are and where you're from. That'll be really good for us to gauge the level of interest in this particular topic, and also the attendance, etc. I noticed that Mike Ball has started the process. Thank you very much, Mike. So yes, Alex. There is a question. Yes, you will get a copy of the slides. Those will be made available on the EMESRT website, as well as I think ICMM are going to be distributing not only the slides but the presentation as well. So we will send out a notification to all attendees via EMESRT as to the location of the slides and so on. So thank you for that question. But please do take the time to add your name and where you're from in the chat functionality. That'll be appreciated. So we're going to now move on to section 3, part 1, where all of our presenters are going to have a presentation in this particular section. So they're all going to be contributing, which will be quite interesting. We're going to start off with Tony Egan. Tony, if you wouldn't mind, please.
Thanks, Eve. I seem to be getting the screen updates again, so I'll give it a try. Let's go to the first slide, please.
Yes, so it basically goes through the section and what we will cover, but if you wouldn't mind just going through that, that'll be great. Can you see that?
Yeah, I can. So I'm going to cover what we call the storyboards, and I'll explain those in a minute. Another key piece of work that I mentioned earlier, where there's been an industry working group of 145 or so people around this ACARP proximity detection validation framework. You know, one of the things we found early on in this process, there was no common methodology for testing these systems. The knowledge hub that I spoke about earlier, Mike's going to actually give us a run of that. They've provided some great support, not only to EMESRT, but also a similar knowledge hub approach for the ICMM initiatives that are going on. And Mark Gearson's going to run through the self-assessment review. And I'm going to talk to a bit more to the work breakdown structure I mentioned earlier. And next slide, please, Eve.
Ready.
Yep. So yeah, I've got a shadowed screen. I'm having great fun with my technology tonight. So anyway, there it goes. So what's a storyboard? Well, Ian mentioned the scenarios before, the 24 scenarios, and you know they came about in the sort of 2013 to 15 period and were a pretty good piece of learning about where the common interaction problems were for us. But at the point in time, we didn't see a lot of change in what the designers were doing for us over the last few years. So we started looking a bit more deeply, and in a project that I'm involved in, we started to work with a particular designer, and we had truck drivers sitting in the room with the guy that codes the software. And between the two, we actually started to work out a way where we could get those deeper user understandings of what actually happens out there to the guy who's actually trying to code the stuff. And as an industry, we as users really have never provided a really succinct approach to the designers. And no disrespect to them, but they've been doing their best efforts from their side of it, but they're not users. So the storyboards are trying to bring together both the functional requirements that come out of the control framework stuff, as well as quite specific scenarios. One of the problems that, and Ian mentioned it, was over-alarming or nuisance alarming. And so what's a nuisance alarm? It's anything the operator hears that doesn't provide context to them. If it doesn't provide context, they're going to ignore it. And if it happens a lot, then you're going to get lots of ignorance. And then the fact is, the design of the system is leading someone to a normalization, and they will ignore something really important. So what we've found is that we need to actually code this stuff down to quite a specific level. So 2 intersections. In our business, I know we had a fatality, unfortunately, in 2013 related to a scenario around a T intersection. And they're very difficult. They're actually, when you sit down with the designers and we talk about the logic, it's been one of the toughest ones to go through. So, this general collision avoidance systems, for want of a better term, have been, the way I describe it is they've been coded at sort of a 10,000 feet view, and maybe some people got down to 5,000. What we're trying to do is get down to 5 feet here and really understand the discrete scenarios in such a way. So instead of those what I call the 2D versions, these are the 3D versions. And the feedback so far from the major designers and third parties has been really embracing of this approach. And even the people involved in the PDS testing methodology, are sitting there going, wow, we can test for this using these approaches. So next one, please, Steve. By the way, we'll actually distribute the file for these, and they're quite interactive. They actually, you run them on PPS and your PowerPoints, and they actually go through. I don't think maybe it's updating for others, but it's not doing it on my screen. Another example where we found, when we analysed the data and what's going on, we talk about the collision avoidance and proximity detection, but one of the big things is loss of control, which happens prior to those events. And one of the key ones we've found in terms of incident data is the wet roads, either be overwatering or in some cases correctly watering, but a truck driver not actually being aware of the wet road line and then getting it wrong and therefore losing control. And it's more prevalent than you think. So what we've tried to do with this approach is actually script out where we could follow a water cart using the GPS approach, leaving breadcrumbs, and then anybody entering that area for a given period would give indication of the wet road ahead. So it's these little simple things. It's about situation awareness that actually is trying to, it's back in that level 7 area. It's not about being up in 8 and 9. It's stopping the stuff before you get there. Next one, please, Ed.
Ready.
Okay. Yep, still waiting to update.
Okay.
Well, here it goes. Yeah, another common situation is where a light vehicle is trying to enter the hazardous zone of a heavy vehicle. We started out with thinking this was one scenario because light vehicles enter heavy vehicles. By the end of it, we've actually got 7 different variations of this, depending on what's happening. And I don't think any of us could have seen that when we started the process. So again, it's getting that granularity of understanding around the performance levels. And if anybody that's ever been in an open cut mine and tried to call up a truck to either board them or get near them, the radio traffic is a real problem. One of the things that this approach does is actually gives a digital handshake, and using a series of what we call safe state, so 0 speed, not in gear, park brake on, etc. And that's where the truck's got green there. Using that safe state approach, you can actually really cut down two things: one, on your radio traffic, but also you can actually log and document when and where those interactions occurred in terms of requests. We can't do that today. And I know Ian in his days, a few years ago, tried to do this with digital radios, which was very difficult. Next slide, please, Eve. This is just another variation, which is, you know, you've got a vehicle that doesn't have an operator in it per se, and you know, how do you actually board it if you don't know whether someone's in it or not? So the system can actually, using an additional signal of ladder down, can actually let you in there. But if at any time one of those safe state points is lost, the system will alarm both the light vehicle and the heavy vehicle. I think this is the last slide, Eve, on these ones.
That's correct, Tony.
And what I'd just like to say is that these storyboards, I think, are really starting to challenge us the way we think and document stuff. But we see these as being overused as operator training. It's the designer can work off it. You know, there's a whole range of things you can do with this because it's quite succinct and gathering the key information. Thanks, Ed. I'll throw it back over to the others.
Thank you very much, Tony. Okay, Ian, I'd like to on you, please.
Thanks, Stephen. Look, Tony, just to follow on from Tony's PC, if you take those 24 scenarios that we had, building those storyboards out provides a really valuable insight into what we're trying to do and how complex that one statement can be. As Tony showed you, there was seven scenarios based on one statement or one picture, and it can change quite rapidly. I suppose another part was, in early 2015, and I'll just give an overview of this PDS, which is Proximity Detection System project. I first teamed up with a bunch of the other industry bodies and put forward a project that will leverage a research opportunity. ACARP funded the project with in-kind contributions from research entities and PDS suppliers. And it was stood up and it's now progressing extremely well. The project developed a three-phase approach to create a unified industry field verified PDS validation methodology. I think that's a pretty important word, validation methodology. It combined the best elements of the Mining 3 body of work and also the University of Pretoria's testing procedures. So it wasn't trying to derive answers, but it was giving a methodology that people could use and repeat to get outcomes. Overall, the project aims to deliver a standardized scientific and objective testing guideline that have been industry verified and utilize the best components of the Mining 3 body of work and also that University of Pretoria testing procedure. We're currently now in phase 3 of the project with several rounds of testing being scheduled over the next few weeks at the Mining 3 testing facility located at the University of Queensland farm at Pinjarra Hills, and also further work being done at the University of Pretoria again. You can see there the picture on the right of the testing facility that was set up at Pinjarra Hills. The old truck that we've got there, and I said we've been given in-kind support from many of the suppliers to put their equipment on there and really validate these testing methodologies. There is no current rigorous method of verifying the statement of intent of proximity detection devices, and these reflect the actuality of the system performance once implemented. The guidelines that we're working on will provide a path for mine sites and third-party testers to engage with the PDS suppliers to mature the development of PDS units towards a higher standard. And I think that's another point, is how do we get to the highest standard we can get to? Aside from this tool being, an invaluable tool for the mine operators in evaluating and selecting systems for implementation, the validation framework is expected to also bring much value to the PDS suppliers, vendors, in providing the correct performance targets to work towards during the product development process. And being able to get those methodologies up front and early, it allows the designers to really understand their thinking and what they're trying to achieve. Apart from this guideline, another deliverable set by the ACARP monitors was the development of the PDS sensing capability assessment document. The draft of that document currently is well into development by the project team and is set to be published shortly. The PDS Toolkit website has been launched. It was only launched today. It was a little bit late. It was supposed to be yesterday, but it's now been launched today. It's a high-level summary of the document. It includes an interactive service sensor attribute chart. On that chart, the users can toggle between many sensors such as a LiDAR, a radar, and cameras, and really understand what those sensors mean and how they interact. The project team are also planning on adding the test results from the site testing, as well as the drone footage, imagery, and other information pertaining to the project onto these websites to provide a more fuller indication of what the testing methodologies meant and how the tests went about. Look, it's all really exciting work and industry leading. I'll hand over to Mike now, who's going to talk more on the knowledge hub that's being developed.
Yeah, thank you, Ian. Good evening, everybody. Just briefly, I want to touch on the 4 points in the right-hand panel. EMESRT is committed to making user or operational site user information available to the industry to assist them addressing real-world occupational health and safety problems. Currently EMESRT is working in 3 industry projects that are developing knowledge hubs, one on equipment fires, one on tyre and rim management, and a third on vehicle interaction. The intent is to use a series of navigation aids so that people can quickly find information that's relevant for them and adapt it for use in their circumstances. The type of resources will include case studies, reference information, links to external websites, and other curated resources. In particular, resources about or templates to assist with running improvement projects at operating sites. Some of you may have been involved with work being undertaken at the ICMM level, where they have the Innovation for Cleaner, Safer Vehicles has a vehicle interaction hub. The EMESRT Vehicle Interaction Knowledge Hub is designed to be complementary and as I said, with that practical focus of how do we make operational change on the ground. Illustrated in this slide is the initial key navigation or a navigation aid called the EMESRT Journey Model. And that really is following a typical sequence for an organisation becoming aware of an issue and starting to understand the scale and scope of it. And then, as all good engineering organisations do, designing or implementing solutions. The important one here, of course, is, as we've seen with the level 1 to 9 models, is the solutions are operationally integrated and consider both design, all levels, design, operate, and react controls. Thank you, Eve.
Thanks very much, Mike. I'll hand over the next part of this presentation to Mark, who will be presenting us with the maturity framework. If you would mind,
Thanks,
Mark. Thank you.
Thanks, Steve. As Tony mentioned, from about 2015, vehicle interaction work started becoming sort of more real. And in 2016, EMESRT recognised that the design investment to solve the vehicle interaction problem was massive. There was something like 60 billion spent by automotive on an annual basis, and approached the ICMM Risk Committee to expand the common industry voice on this vehicle interaction problem. So in October 2018, the International Council of Mining and Metals launched an initiative called the Cleaner, Safer Vehicle. And the ICMM is a group that brings together 27 of the world's leading mining companies and some of the best known truck and mining equipment suppliers, with the purpose to accelerate innovation and develop a new generation of mine vehicles. So in the context of vehicle interaction, the The program aims to promote collision avoidance technology capable of eliminating fatalities from vehicle interactions so that it's available to mining companies by 2025. Now, this is a very good place to start for those on the call who might be interested in understanding more about existing maturity, their own existing maturity, and to promote and commence that internal discussion. Next, thanks, Steve. So early in the presentation, we heard a little bit about the EMESRT Control Framework, a process where we understand our required operating states, our credible failure modes, and how those business inputs support us, specify, implement, and monitor as a means to maintain a healthy state. So this self-assessment tool, self-assessment review guideline, self-assessment tool, is Excel-based, and the business inputs have been categorised into 5 key groups. And I've listed several examples there, and they come under the same things that we see in our organisations now: personnel, equipment, work environment, interactions between working groups, and system optimisation. Thank you, Eve.
Okay, I'll hand over the presentation now to Tony, who is going to present operating site application. Please, Tony.
Thanks, Eve. Just waiting to update. Okay, so I mentioned earlier about the work breakdown structure. So if you're going to head off and do this stuff, the reality is it's not just go and ring somebody up, order a bit of technology and let them come and install it and you'll be fine. You've got to manage this thing as a project. It's quite a significant cost on a direct basis, but also it could be a large indirect cost as well if you get it wrong. But even if you do get it right, there's still a lot of indirect costs. So this by anybody's measure is a significant dollar investment in capital, but also an ongoing investment in operating. So what we're saying is, start out, Mark just mentioned about the ICMM maturity framework. Well, you know, the first box on the left there is project management. Treat this thing as a project. And we see that the maturity framework can be used in helping coordinate the stakeholders and getting people agreed on a project charter and a scope, and getting people's heads aligned and pointing in the same direction. It's not a technical document, and it's not meant to be. It's about starting a discussion within your business. And if someone thinks, oh no, we're really mature, we've got this and this, then someone else says, well, no, I think you're actually less. You're probably both somewhere in between, but the discussion that you have about understanding each other's perspective is really going to set you on a course to alignment in your business. I mentioned earlier about the control framework, and the step 2 there is actually about setting a baseline. So in other words, you know, we've all invested money and time in our assets and our procedures and our existing equipment, and they're all things we've invested in. And rightly, we should be trying to squeeze out of those everything we can. And so the baseline in terms of capturing the control framework, and the self-assessment guide there can be used in this process, is about capturing that baseline and saying, well, we say we do these things. Are we doing them? How well are we doing them? And what you tend to find when you do this baseline is that there's quite a bit of improvement, both at a procedural level, and also it starts to highlight that even if you did things exactly how you specified, maybe it's actually not going to get you there. So you might want to do something different. I've lost connection again there, so I'll just go on to my slides. The next step is, okay, well, I've done my baseline and I've got some gaps. We'll go and close those. And what we called it originally was control effectiveness. In other words, I'm doing something, is it effective? And if there's only 2 reasons. One is it doesn't actually address the issue, or 2, it does, but you're not doing it properly. So go and do that exercise. And then having squeezed the thing and got the value out of that process, it sets you up to then say, as Mark mentioned, you know, help me do better what I do now type technology. So step 4 is really saying, where might I use some technology or some improvement change to change what my baseline is, even having improved it. So a good example would be the fatigue that I mentioned earlier. That fits in level 5 in the operator fitness for work. And another example could be moving from road rules to a vehicle hierarchy, which is, little vehicles giving way to the big vehicles. I think it's those sorts of changes. We've certainly got some data now that shows us it has had a significant effect. And once you get through that process, then you sit there saying, well, I've absolutely squeezed everything I can out of the existing systems with a bit of addition, and I've still got some exposure. So that's the level 5 is about looking at proximity detection and potentially collision avoidance in that space, all the way from 8 to 9. And this staged approach actually will really set you up to invest properly and understand all the steps along the way and bring your people through. The last step in 6 is, if you were to start a new mine tomorrow, what's that mine in the future look like? And I think there's several people in the industry going through this process at the moment, and hopefully what we don't have to do in a new mine is learn the problems that we had back in these existing operations. This gives us a window to how we can actually improve it. Thanks, Eve. Next slide, please.
Ready?
Okay. So, in terms of supporting the industry, you've seen a few models and some examples, and I said in the last 12 months, we've come forward in leaps and bounds. Even that diagram up in the top right-hand corner, came out of an exercise about 6 months ago where we took the 9-layer model and put it into a more visual approach about where things sit. And this has been really well received by the non-practitioners and particularly senior management people. So, EMESRT is all about, clearly defining a problem and confirming understanding using operational scenarios. And I think you've heard us talk about that tonight in the vehicle interaction space, but we've done it in other topics as well. But particularly in the vehicle interaction space, it's stood us in good stead, I think. It's taken us a while because it's a complex issue, but we're getting there. The other thing is, don't jump to solution. And we've seen lots of examples of that when we go around the industry where people just jump to the silver bullet. And then, unfortunately, we're aware of a woman who was killed in South Africa. The systems were fitted. In this country, there's many systems being fitted where proximity detection, and we've still had the issues. And operators were normalised to things, the alarms. Ian mentioned several of the problems. So, I talked to a legal guy once, and he said to me, Tony, it's probably more important that you know what these systems don't do more than what they do. Because if your people aren't really aware of that, then you've probably got a major issue. And then the last point there on the approach is you've got to challenge your current thinking. I mean, I think if you said to people, you need to improve your baseline systems. Oh, no, everything's fine. They're going okay. Well, the answer is, if you really dig deeply and looking at it in a different way, not our traditional approach, we've had to approach this differently using the control framework. And I think in the words of one of my colleagues, Tony, we're looking at the same stuff, he said, but we've just used a different lens. And it's given us great clarity about the connections. And I think that's been the real step forward for us in this period. And just to reiterate again, that there's that operational innovation is help me do better what I do now versus replacing what I do now. And if I think if you're thinking that the technology is going to replace what I do now in this space, you're probably going to be sadly disappointed if you think it's going to do great things for you. What we're finding is it can do quite specific things of reasonably low logic for the price point that people are prepared to pay. We did an exercise this last year where we looked at the sensing technology. We broke these systems down into sensing, rules and intelligence, and interface. And when we looked at the 3 levels and looked at sensing, for instance, the price points of the current products on the market really only provide very low sensing quality, and therefore you're never going to get the level of detail and accuracy that you're looking for to get rid of nuisance alarming, etc., and to deal with these complex scenarios. And I think that's the real issue for everyone. If you want the sort of expectation of the sensing people thought they were getting, well, that's really at the autonomy level. And there's a real price point difference here. And there's a tipping point. You know, how much are people prepared to pay? And we can't walk away from that. So it's the old story about you pay for what you get. So just a word to the wiser on that. Next slide, please, Lee.
Ready?
So overall, there is a compelling case for improvement, and we've done 7 years of work at an industry level on this. By the way, when we had the first meeting in 2013, there was 7 or 8 major companies came together, and when we added up the money that had already been spent prior to 2013, it was in the order of $35 million, I think. So it wasn't like people haven't been working in this space, but it was really only by bringing the industry together we're starting to get some real traction. And the good thing, I suppose, for everyone else in the broader industry is that the extensive resources now available, and we're really looking to populate that knowledge hub and other things so that people don't have to keep relearning this stuff. And I suppose from the group in general, we want to let you know that, you know, at the end of the day, this is a complex project that you're taking on if you're going to do it. You've really got to manage it and coordinate it well. There's no silver bullets, and we keep mentioning that because it's been a real problem, and it continues to be with people who really don't understand what the complexity of this stuff. The other thing that EMESRT is going to keep doing is trying to facilitate this work across the industry and keep the moving parts together. We're by no means going to solve it ourselves, and we're not professing to. We're interacting and integrating with lots of different people across the industry and sharing freely. And I think that's been the real benefit of the industry work. You know, one company does some stuff and we all share it, and we all learn from that, and we leapfrog each other. And I suppose the rest of this year for us, we think is a year of delivering some good outcomes at a usable level. Ian mentioned it a couple of times, but you never want to be operating in the red zone, because if you are, it's your last chance. What you want to be doing is, you know, operating in that normal zone. You drift into abnormal, you get a trigger that allows you to come back from that abnormal state into normal again. The real worry is if you're not getting that trigger and then you continue to drift and then you move into the imminent threat situation. And that's where that sort of technology at level 8 and 9 is. So the ultimate end of this is that it's not just about the operator in a cab, it's about the supervisor getting information as well in real time that allows them to intervene in things. And as a manager of a mine, looking at the trends in behaviour and operation around the things such as mentioned before about maintaining clearance, speed, you know, parking correctly, giving way. The other thing that these systems do at a very base level, and it's really about at a level 7, is they give you incredible amounts of information that you didn't have before to start making better decisions. But you've got to go looking for it. If you just stick it in the cab of a truck and think, oh, I'll let the operator know what's going on and then it's all going to stop from there, you're probably not going to extract the value out of these things that you can. Thanks very much, Eve, and thanks very much for everyone listening this evening and making your time available. It's certainly been a good exercise for the EMESRT group to force us to distill our thinking, which often is difficult because we've all got day jobs and we do a lot of this stuff in addition to what our normal jobs are. Thanks very much.
Thanks, Tony. I just want to go around the room via the chat functionality, if I could, and just see if anyone has any final questions for the presenters. If you do have a question and you miss out tonight, please do send me an email and I'll get the guys to respond. My email address is emcdonald@mining3.com, or you can send an email to the inquiries@emesrt.org. But before we do go, like Tony said, we really do appreciate your time. I want to thank Peter for making all of this possible, and also to our presenters. We all do have day jobs, and this is something that the whole group is passionate about, so we do take the time to put extra effort into communicating with the community as to what we're doing and so on. Thank you to everybody who did attend the webinar. You will find the slides on the EMESRT website, and I will communicate that to the EMESRT VI working group. And Pete will make it available via the ICMM website as well.
Hey, Eve, just a quick one. There's a question there from Colin, and I think it's a really interesting one. How many collision avoidance warning systems are in place across Australia mining operations? it'd be an interesting one to find the facts of how many have gone in and how many are not working and have been removed and how many are actually up and running. But there's probably at least half a dozen around Australia that are probably up and running, I tend to think. Tony, what's your views?
Yeah, look, there's been systems in this country since back in 2005. I think it was one of the first ones that went in.
Yeah.
And certainly Anglo-American put a serious amount in following the 4 fatalities they had in South Africa in an incident where 4 supervisors were in one light vehicle and run over by a truck. The issues over the years, but we've talked about in terms of nuisance alarm, normalisation effects, etc., have continued to pervade. So, yeah, there's some systems running, and like anything, you know, every time you do something, you learn from it, and we have been. But I think for those people that have put these systems in, they would probably tell you that, you know, it's quite significant. I know I went to one mine in Western Australia where they had a system running, and 4 of us rode around in separate trucks. And the final question we asked the operator was, if we turned this thing off this afternoon, would it bother you? And interestingly, 3 out of the 4 basically said no, because they were driven mad by the over-alarming. And the third one said, oh, well, I get a few things out of it. So the fourth one said a few things out of it. But yeah, you're right. I could probably live without it. And so that's telling us we've made this massive investment and we're not getting the value. While I've got the floor, there's 2 other questions that I saw. Peter, you wanted to know how much radio traffic would be reduced by the digital handshake approach in one of the storyboards. The superintendent who was involved, mining superintendent who was involved in that process, immediately sat in the room and said, you know, I reckon this will cut it by half to 2/3, which is pretty significant. I mean, that's anecdotal, but that was his view of the world. And the other question was, there was from Ting from University of Wollongong, was asking about big data and connections and how that all fits with the 1 to 9 model. Yeah, look, I think we're biting off what we think is the fundamentals at the moment. But I think as people grow into this, already the work we've been doing with the major designers are seeing that when you start talking about decision-making at a supervisor and a manager level, it starts to want to pull data out of the system that's never been pulled before. And that has really challenged the designers of some of these systems because they were just focused on the operator. So who knows where it'll go, but I think, it's the more we have, the more it's going to help us change our decisions.
Yeah, and look,
Thanks,
Tony, there's a couple other questions here as well, and I think I might answer the one from Colin where he says, over-alarming is still the problem after so long, exclamation mark, exclamation mark. I think it's a very, very important point. Over-alarming will always be a problem if you're relying on level 9, 7, 8, and 9 to be the answer. If you can move further down to the level 1 and 2 scenarios of that 9-step model, it reduces the number of interactions that allow alarming to happen. And I think, over-alarming is still very much a problematic thing. And the piece that goes with that, and I think, Tony, you're probably the best to answer this one as well. I think you have to be careful how you answer it. How do you manage the human drift to rely on the systems and change their behaviours and stop behaving as they should?
And that comes back to what I was just saying about the data for the supervisor and the manager. One of the key things we've seen in the fatigue space is that, yes, the person that gets an indication that they've had a microsleep and a voice and a seat shake maybe wakes them up. But the supervisor gets data immediately that says there's been an event and you may need to intervene. And the manager starts to get data that says, well, the same person's having the same problems over and over. So you can start to do health interventions. You can start to look at how these people are preparing for their shifts, et cetera, et cetera. So you're starting to get information rather than just data that helps you make better decisions. And I think what you'll see is the ability to change behaviour is quite significant. And there's already been some of that with the advent of some of the light vehicle monitoring systems where speed and aggressive driving and braking, et cetera, are monitored. And we're seeing a massive reduction in the light vehicle-related issues, such as rollovers, etc. I mean, young men in mines are predominant in that fact, and I think you're starting to see a great reduction in that space. So, yeah, you just can't let it go, and you've got to act on it.
Yeah, I think, Tony, the other piece of that piece is, we know that humans will actually start to rely on these systems, and therefore it makes it so much more important that we get it right, because if we start getting it wrong and people start ignoring it, it's going to enforce the wrong behaviours. And I mean, we do know that people rely on these systems. Getting that piece right up front is so important to the success of any system rollout.
And good point, Anne, because it's Mark here. That's the danger about implementing an inch-wide, mile-deep, single technical solution to solve one portion of this maze. Because if you do that, you may actually, because of the change in behaviour that can be brought about, create an environment that is potentially more hazardous than the one you're trying to plug.
Just on that, I presented to the Mine Safety Advisory Board in New South Wales a couple of years ago about where the maturity of these systems were on behalf of EMESRT. And the chair of that committee, Carl Scully, who was an ex-minister for the government, he sat at the beginning and said, we've got autonomy. Surely we should be able to do this with manned vehicles. Well, at the end of the presentation, he stood up and he said, well, I've learned a lot today. He said, it just explains my wife's behaviour a few weeks ago. He said, we live on the north shore of Sydney, and we've got a big hedge down the side of our property. My wife was backing out onto a major road down past the hedge when she was nearly cleaned up by a truck. And she complained bitterly to me that, it didn't tell her that the truck was coming. Well, it's a really stark example, because when he said it, I knew he actually got what we were telling him, because it's a stark example. If she had an expectation, it did something that it didn't do. And so she made a judgment on that basis, and it could have led to bad consequences. And we've got examples in operations around the world already, where the proximity systems are in place, where operators have made judgments that probably they wouldn't have made had they not had the system. So that human factors piece is so important.
I can see, what else have we got? There's a couple of questions popping up. Tony and Ian, can you read those? Are there any that require answering?
Yeah, I think, Colin's just put one in here. South Africa and other countries have legislated for collision avoidance systems must be in place. What do the Australian regulators think? I think Tony and I met with the regulators quite some time ago now when we first started down this journey. And, we explained, that the systems weren't what the sales approaches were saying they were. I think the Australian regulators did a really great job. They gave us the leeway. I mean, I think they gave the industry the kick in the butt it needed to get moving on doing something, and certainly EMESRT took the message loud and clear that we needed to get something going. But it's given us the leeway in the industry, leeway to work on this so we get the right solution. But there's certainly a lot of expectations I believe, from the Australian regulators to move faster and get these things, to the state that we need them to be. I just wonder if there's anybody online that would like to make a comment to that, or Tony or Mark.
So just on that, Ian, everyone sort of looks to South Africans because they've gone to level 9 intervention. Well, I think they're already 2 years past the original date, and there's the work that EMESRT is doing is very interacted with the South African guys. We've got through the ICMM work and others, there's a lot of connections. And I think what's the maturity of the work that we're doing here is being seen over in South Africa now and saying, hey, we better bloody walk a bit carefully. And then the other fact is that they need something like 20,000 systems deployed in the next 6 or 12 months. The scale of the task is just enormous, and the scale of the support people to required. I talk about day one, you might get the system running and you may get it doing what you want it to do, but the real challenge becomes at day 500. Have you got it? Have you still got it running? And is it still performing how it should be performing? And I think that's been missed in this whole exercise, in this push towards just get the technology. You've got to be able to sustain that as well.
Tony, one thing to sort of support those on the call, if anyone has anything that they'd like to contribute or be part of, you know, this solution, please feel free to reach out through our contact details on this slide, and Eve or we'll put you in contact with one of the EMESRT AG members if she can't deal with it herself.
Thanks, Mark.
Absolutely.
Okay. I think one thing I'd like to, one thing I'd like to finish on that sort of builds on what Mark just said is that EMESRT over the years has tackled some industry issues, and this has definitely been the hardest one. But it's through the diversity of thinking and the diversity of people involved that we've made breakthroughs on things. And, you know, none of us are so bold as to think we've got all the answers. It's about trying to facilitate bringing everyone together to find the answers we need, and by thinking at a different level, challenging ourselves. There's a really good quote that I've ended up tracing back to Einstein, and he said, "A problem will never truly be solved at the level of thinking at which it was created." And this is certainly one of those topics that if we don't think at different levels, we're not going to get on top of it. Thanks, Eve.
Yeah, yeah, it's Mark here, just building a little bit on top of what Ian's and Tony have said as well. You know, light vehicles have typically got a life of you know, 3 to 5 years before people turn them over, but we buy heavy assets. You know, and those assets last for 15 and sometimes 20 years. So, you know, the technology that's in those base machines, if we're talking about trying to deploy something now on a machine that's already 10 years old, may only be incrementally available because of the inherent infrastructure on the machine. So there's a lot of issues, and I see a question, I think, on the board there, which talked a little bit about Toyota, and others are talking about vehicle-to-vehicle comms. And EMESRT actually saw that there was a bit of an issue with regard to the communication platform, and that's where ICO 21815 came from. So it was really around building a platform. So as these sensors evolved and became more tunable to our particular needs with less noise, then we could plug and play. And I think we're starting to, and the other thing that did was also make it, you remember early in the presentation, we talked about the commercial reality of things. You know, people aren't going to put money into development of stuff if they don't understand what operating platform their particular product's going to be referencing. So,
Mark, just if I could add to that question on light vehicles manufacturers, EMESRT did talk about this, but one of the things we've done at the ICMM level, and I'm actually on the steering committee for the Cleaner Safer Vehicles Initiative, and also on the vehicle interaction subgroup for that. Using the might of 27 member companies, this one of the actions that will be coming out of that for this year, the latter part of this year, is approaches to the light vehicle manufacturers from an ICMM perspective, which comes with a fair cloud of credibility.
Because our sites require that interoperability. You know, it's not a single machine solution we're kind of looking for in our mine sites. It's something that's interoperable, right? You know?
I think it's back to Eve anyway, gents. Thank you for the questions, and
thanks, Tony.
We'll look forward to some more, I'm sure, as people think about these things a bit further.
Yeah, we did start to get some serious discussions there in the end. Thank you, everyone. We won't keep you any longer. We're due to finish in a minute or so anyway, so appreciate your time. Please do flick me an email if you have any further questions or want to know more about the group. Thank you, and I wish you well. Stay safe.